Hi, algebra students. Today we are starting topic 4. This is lesson 4.1, and we are talking about how to solve linear systems of equations by graphing. So we are going to use some graphing today. I want to make sure that you recall how to graph by hand, but because the focus of the lesson is not actually on graphing, it's trying to determine the solution to a system of linear equations. We are also going to use the Desmos graphing calculator. So if you open a tab for the Desmos graphing calculator, that will help you a lot today. So first, I'm going to start by defining what a system of linear equations is. And that is a set of two or more linear equations. We call it a system because we're looking at how those equations interact with each other. In Algebra 1, you're only going to be dealing with systems that have two equations and two unknowns. So mostly what you're going to see are lines in slope-intercept form. Now, sometimes our lines might be in a different form that you will have to manipulate so that they are in y-intercept form, because that's the easiest form to graph from. So I have these two lines, y equals negative 2x minus 4 and y equals 1/2 x plus 6. And I am going to draw a graph for sake of just showing you and reminding you how to graph by hand. So if I want to graph this line, y equals negative 2x minus 4, you need to start at the y-intercept, which is negative 4, which is right here. And then the slope is negative, but I can't really go down any further. So I'm going to go up 2 and to the left one, up 2 and to the left one. And I'm just going to keep going until I'm pretty much off the graph so that I have as many dots as I can have to make this line. And then the same thing with the second line. I'm going to start at the y-intercept 6. And the slope is positive 1/2, but if I go down 1, then I'm going to go to the left 2. Now, remember, I said that we call it a system because we're trying to determine how these equations are working together. The solution to these equations is where they are intersecting each other. So the solution the solution to the system, because it's not the solution to just one equation, it's the solution to both equations, is the ordered pair that works for both equations. And we're going to call that the intersection point. So where these two graphs are intersecting each other. And at this point, this is the ordered pair 1, 2, 3, negative 4, 1, 2, 3, 4. And you can always check your work by plugging this ordered pair into both equations and making sure that it does. So if I plug in 4 for y and negative 4 for x, I get 8 minus 4 equals 4, so that one works. And then 4 equals 1/2 times negative 4 plus 6, which is negative 2 plus 6, which equals 4. So they both work, and I just double checked. Now, we're going to, instead of graphing these by hand and having to manipulate, use Desmos as a graphing tool. And I'm going to show you how to use Desmos on this example, but then on the other examples, I'm going to just do them by hand because it's going to take me more time to type the equations in than actually graph, whereas it might be a little bit different for you. So I'm going to go ahead and share my Desmos screen with you really quickly so you can see that when I am looking at Desmos, they give you spots where you can type in the equations. If you type those equations in just as you see them in your book, and then you can find where they intersect by clicking on that point, and it tells you that ordered pair is negative 4, 4. And so you're able to see that ordered pair from the graph very quickly after you type those equations in. Okay, so we're also going to talk about systems of equations that have special solutions. So if I'm talking or looking at another system of equations, and I'm going to say 15x plus 5y equals 25, and y equals 5 minus 3x. And I should have done these in colors, so I'm going to do that really quick. Okay. And I'm actually going to manipulate this one just a little bit because it's easier to graph if it's in y equals mx plus b form. So I'm going to subtract 15x, and then I'm going to divide by 5. And when I do that, I end up with y equals 5 minus 3x. So I'm going to notice something very fishy here, but I'm going to go ahead and graph it anyway. Now, I'm going to have us sketch these in our notebooks, but you can also use Desmos at this point to graph these lines. My y-intercept is 5. So I'm going to put a dot and then go down 3 over 1, down 3 over 1, and sketch my line. And my orange line is also y-intercept 5 and slope down 3 over 1, down 3 over 1. So I'm going to sketch that line as well. And it turns out that these two lines are actually the exact same line. So every single ordered pair that's on these two lines is a solution. And these two lines go on forever and ever and ever in both directions. So there are infinitely many solutions. And I could have told you that from the very beginning because I know that when I get two equations that are the exact same, I'm going to have the same line, which is going to be infinitely many solutions. So if I notice that they have the same slope and the same y-intercept, then I'm going to have the same line and it's going to be infinitely many solutions. I'm sure you can guess what the next solution is going to be. And both of these equations need to be manipulated, so I'm going to do that. And then I'm going to graph them. And again, when you're working on your homework, you can use Desmos to make this a little bit quicker for you. And we have y-intercept of 6. And I only went up to 4. So I'm going to go 2, 4, 6. And then it goes up 2 over 1. So I'm going to go both directions. And then this one has a y-intercept of 4. And it's again up 2 over 1. So these two lines are what we call parallel lines. They have the same slope, but different y-intercepts. And if they're parallel, they never intersect each other. So there is no solution. Okay, so you're looking at the two lines to determine, do they intersect always because they're the exact same line and have infinitely many solutions? Are they parallel and never intersect, so they actually have no solutions? Or do they intersect each other and the solution is that one ordered pair where there's those two lines intersect? And then you will also have story problems where you have to write your own equations. And then again, using graphing, you can determine your solution. So this problem reads, Monisha and Holly have 14 more days to finish reading the same novel for class. Monisha plans to read 9 pages each day, while Holly plans to read 20 pages each day. So I'm going to just make some notes here. Monisha is going to read 9 pages per day. And Holly is going to read 20 pages per day. Monisha starts at page 96 and Holly has read to page 6. So Monisha's at page 96 and Holly is at page 6. Assuming Holly and Monisha both maintain their reading plan, when will Holly catch up with Monisha? Who will finish reading the novel first? So we need to write equations for these. The amount of pages that they read per day is the slope, and the y-intercept is their starting point. So I'm going to write those two equations. Monisha is y equals 9x plus 96, and Holly is y equals 20x plus 6. So if we want to graph these, because I'm not going to graph this one by hand because starting at 96 and that is going to be a huge graph. So I'm going to go ahead and switch my screen over to Desmos again, and I'm going to type these equations in for you. So y equals 9x plus 96, and then y equals 20x plus 6. So at this point, we can only really see Holly's line. And so I'm going to zoom way out. There's Monisha's line. And then what I'm looking for is where these two graphs are intersecting. And it's right here. So I'm going to zoom in at that point. And it's going to be difficult to see because these numbers here are very light. But we're looking at when do these two lines intersect. And if I click, I should get a point that is very close to where they intersect. So I'm going to go ahead and write this in my journal. Okay. So I'm going to switch back now to my document camera so you can see it. So they catch up at this X point of 8.182 and this Y point of 169.32. So what this is telling me is that After about 8 days is when Holly is going to catch Monisha. And we don't know exactly when because it's giving us this decimal, and that's going to be how many days after. So if I plug this in for both Monisha and Holly, we're going to do 9 times 8.182 plus 96, and I get in my calculator 170. And Holly, I plug in 20 times 8.182 plus 6, and I also get 170. So after about 8 days, Monisha and Holly are at the same number of pages, and so that is when Holly catches up and she begins to pass Monisha. Now, we kind of had to round this one because it wasn't making a lot of sense as a decimal. Yes, days have decimals because we can talk about the hours after that day, but really, we are not going to want to use graphs when we're looking for exact answers. So I'm just going to make a note of this. Looking at a graph to find exact answers is difficult. So we have other methods, and we're going to learn those in this topic as well. And really, Desmos is really nice to help us find exact answers, but we're not going to always have access to Desmos when we're solving. So it's going to be beneficial to have other methods for that. So that is the end of lesson 4.1, solving systems by graphing. We're going to go into the other methods next.